First, I will talk about the improvements in Codan support. So we have had some functionality for Codan support, but now we have enhanced it quite a lot, and we are now using CDT built-in compiler settings provider that is updating the target projects and providing information for C++ indexer for Codan. So now I will show you how it is working. So we have an option, generate additional information for code analysis. So this means that we will apply additional settings on the target projects so that code analysis will have correct index according to the settings in the project. So now I will not turn this on, and I will show you what is the problem. Currently, all the projects they are depend on external code, and they can link with some external libraries and use includes from some external folders, and all this is specified in this target configuration. So in my example, I'm using inclusion paths. Here I'm using one path. Also, I'm adding other include in compile arguments. So this is another place where you can specify include for external code. Then also sometimes macros are additionally defined, and here I'm also having compile arguments defining this name equal to Elena in compile arguments. I'm defining an additional macro in my target configuration settings. Also, projects they are using standard compiler definitions and standard libraries, and also C++ indexer should know where are these standard libraries in order to correctly update the index. So now I will build without turning on this Codan support, and actually the build is working fine because the compiler it knows all the standard includes, and also all these compile settings are available in the build command line. And now we have generated two target projects, and if I will try to open the generated code, for example, for the capsule, now I will be getting errors from C++ indexer. So this is a warning. So the indexer was not able to find the external include, and also we're getting here the indexer was not able to detect standard compiler standard functions from standard libraries. Also, this name, I was defining it as a macro in the compile arguments line, and also this C++ indexer did not find this definition. So we can check what we have in the properties. Here for for C++ general, we have preprocessing include paths and macros. And so here, by default, we are generating under these settings, we are generating additionally include paths to target RTS. Also, we are generating include paths which were explicitly mentioned in the include paths option for the TC, and also references to the target projects. but we don't have any information about standard paths. And also we don't have information about any includes which might be added here in compile arguments string. So now I will show you that all these problems are solved by this flag, and this flag will add additional setting on the target projects. Maybe I think I need to do clean first, just to have a brand new target project. And I will run build. Now here in the info output, you see that we have information that GCC built-in compiler settings provider was applied to the generated target projects. And now we can check how this is working. So for the generated target projects, we are automatically applying this provider. So here, CDT GCC built-in compiler settings provider, and you see that this provider was able to discover all the needed include paths that we were missing. So first of all, it was able to discover the include path from the compile argument string. Also, there are include paths, standard include paths. And you see that here as well, we have a number of macros as well provided for the indexer. So now indexer knows about the name that it is equal Elena from that we provided in the compile settings. Now we can check what we have. If we double click here on this capsule, you see that now we don't have any warnings or errors anymore. So the indexer was able to find all of these, and we have a good resolution for macros. So now we see for the standard output functions, for the macros, we see that it was resolved by the indexer. This, if you want to understand how this is working, then here for GCC built-in compiler settings provider, we can check what is happening and how the symbols are discovered. So if we use this allocate console, and now I will all the discovery actions will be shown in the console. I will press clear entries and apply and close. So we will rerun the discovery. And here in the console, we can see that this provider, it invoked the compiler with all the compiler settings. So these are the settings that we have resolved from the TC properties and also from target RTist. So these are all the settings that are used when we run real compilation. And now it is also using special flags, asking compiler to print all the paths and all the preprocessor definitions. And this scanner discovery, it is parsing this output from compiler and updating the index. Compared to what we had before, so before we also had some similar functionality for Codan support, but we were not able to detect macros. So C++ indexer was not, we didn't have support for macros. Also, we didn't have support for include paths, which are specified here in compile arguments. So we could provide information only about include paths explicitly stated in this property. So now this approach is more complete, because for a discovery of all of the symbols and paths, we are using exactly the same command with all the arguments which we use for build. And you see that here we are referencing, for example, this define tag. This is defined in target RTS. So we are able to understand and to resolve all these references to target RTS definitions. And this define tag and include tag here for the scanner discovery functionality, it is resolved, and we have -d, -d, -I. So that's all, I think, for this Codan support. Do you have any questions?
So now it should be able. We should be able with this version to use Codan if we turn on this preference.
We need to do more testing. So we have during this sprint, I was running testing in your environment, and now the results are better than what we had before for the Codan, but there are still some of the macros, some of related to OCE signal and initialization or something like this. So we can have a separate meeting. I will show you what are the remaining problems. So there are still some places which cannot be resolved. Probably this some of the includes are coming from external build spec, and in that case we're not able to pass this information to this provider. So we need to do some more analysis, but definitely now we have much better results than what we had for the previous version.
Okay, thank you.
So I think we can have a separate discussion and just briefly check what are the remaining issues. Okay, so I need to mention that this option, it is supported only for GNU make. So the make type should be GNU make. Only in that case, this GCC built-in compiler settings can be used.